We're going to start learning about factoring trinomials now. And this is a topic that's going to have an easy type we're going to learn in section 5.2 and a more advanced, more difficult type that we're going to learn in section 5.3. Both of the two types that we're going to learn have to do with the opposite of a multiplication technique you learned back in Algebra 1. That technique is called FOIL. First, outside, inside, last. And you know how to apply it in situations like this, x plus 7 times x plus 4. When you multiply this out, you go x times x for first, x times 4 for outside, 7 times x for the inside, and 7 times 4 for the last. But if they're simple like this, where the x's don't have any coefficients in front, there's kind of a shortcut. Just about everybody works it out just by adding the 7 and the 4 to make the 11, and multiplying the 7 and the 4 to make the 28. It's not so simple if there are numbers in front of the x, but when things are simple, like this, you have a shortcut. That's what makes these the easy type. They're easy because x has no coefficient. Since we're learning factoring, we're going to be doing this stuff backwards. We're going to be taking the answer that's already multiplied out and try to separate it back out into the two numbers that added to make 8 and multiplied to make 15. And this is really pretty much a guessing game. You start here because there aren't that many ways to break up 15 by multiplication. Breaking up 8 by addition, there's a lot. There's 1 and 7, and there's 2 and 6, and there's 3 and 5, and there's 4 and 4. There's all these choices for the 8. But the 15, there's only a couple of choices. There's 1 and 15. Well, no, that won't add up to 8. So you throw that one away, and you say, okay, what else could make 15? 3 and 5? Oh, yep, that works. 3 times 5 makes 15. 3 plus 5 makes 8. That's the right pair of numbers to use. There are some slight complications that make this a little more challenging. For example, a problem like this, if you've got a minus sign over here, things are going to be a little trickier. You can't just start out like we did the previous problem and try to figure out two different numbers that are going to add up to 12, because it's adding up to negative 12. And I don't care how clever you are with numbers, there are no two positive numbers that are going to add up to negative 12. So what that means is we're going to have negative numbers. That's not too difficult to realize, pretty straightforward. And other than the fact that they're two negative numbers, you treat this just like you did the other problem. How can we break up the 32? And of the different ways we could break up 32, which ones make 12? So like 1 and 32, no, that's not going to do it. That won't add up to 12. 2 and 16, no, that's not going to do it. That makes 18. That doesn't make 12. 4 and 8, yeah, there we go. Notice what happens when we check. Always check your factoring problems. In fact, let me pause for just a second and emphasize this. If you want to be good at factoring, the only thing you have to do is check every problem you work out. Every time you think you've got the answer, take just a moment to multiply the thing out using FOIL and see if your answer's right. It's amazing. It seems like that wouldn't make any difference, but it actually makes you much better at factoring. Actually checking every problem improves your ability to factor. So, first, outside, inside, last. Notice the negative 4 times the negative 8, negative times negative. That's why we end up with a positive 32 at the end. It works. Now, where the minus sign is, that really matters. Compare this one to the previous one. Here, if you use two positive numbers, there's no way you're going to get a negative 35. That's not going to work. And if you use two negative numbers, that's not going to work either. Negative times negative, like we saw in the problem just a second ago, that's not going to make negative 35. That would make positive 35. So here you have to have one number positive and one number negative, because when they're multiplied together, the result has to be negative 35. Now, once you realize that, the rest of it's pretty straightforward. Well, how can we break up 35? Well, there's 1 and 35, but that's not a very good choice. That doesn't give you 2 in the middle. And there's 5 and 7. Those are your only two choices. But be careful. Once you realize that 5 and 7 is the right pair of numbers to work with, you got to put them in the right places. Like here, if I put the 5 with positive and the 7 with the negative, when you check it, it doesn't check. Here, you FOIL this thing out, you get x squared minus 7x plus 5x minus 35. That gives you the wrong sign in the middle. We're supposed to be getting a positive 2x. Remember this back over here? And we're getting a negative 2x instead. So you can't just jump right into your answer and say, oh, it's 5 and 7, and walk away. You have to take a second to check. And notice that when you check and you realize it doesn't work, you can also pretty much right away realize what it takes to fix it. The 7 should have been positive. The 5 should have been negative. Now it works just fine. Here's another complicating factor. You can sometimes have more than just an x floating around in your polynomial. Sometimes there's letters other than x. Sometimes there's more than one letter. My suggestion is, with a problem like this, do the variables first. They're usually pretty straightforward. Like here, we've got our first terms are going to be A terms, and our second terms are going to be B terms. It's going to be something A and something B in the first pair, and something A, something B in the second pair. And then once you've got the variables done first, second, do the numbers next. So now we don't have to worry about A's and B's, we just have to worry about 14 and 48. So let's see, 48, 4 and 12, no, 4 and 12, that doesn't make 14 in the middle. 24 and 2, no, that's even worse, that makes like 26 in the middle. You have to think a little bit, oh, 8 and 6. 8 times 6 makes 48, and 8 plus 6 makes 14. Here's another issue you may run into. It looks like a simple problem at first, because the good news is you're talking about the number 11. And there's only one way to break up 11. It's a prime number. It's got to be 1 and 11. That's the only product that'll make 11. But if you say, well, there's only one possible choice, it must be right, you end up with a wrong answer. This doesn't check. You're always supposed to check your answers. So here, when you FOIL this thing out, w times w, you get w squared. W times 11, you get a 11w. 1 times w, you get w. 1 times 11, you get 11. You collect your like terms, and that's not the right term in the middle. We're supposed to get 10w, we're getting 12w. There isn't another choice we could have done. We didn't pick the wrong answer, and there was a right answer to pick. This was the only way we could possibly have factored out the 11, and it doesn't give us this 10 in the middle, so this thing does not factor. And if you remember from section 5.1, when things do not factor, what we call the polynomial is, we call it prime. That is a prime polynomial because it doesn't factor. The only way it could possibly factor doesn't work. And then one last example down here is a very important one, because this will take what we're learning right now and connect it back to section 5.1. Here, my first piece of advice is always pull out a common factor first. So from this thing, if you look through here, there's a common factor of 3 and a common factor of x, and that leaves x squared plus 5x minus 14. And then after you've pulled out a common factor, the pieces you have left may factor further. In this case, what I'm talking about is the x squared plus 5x minus 14. That's like what we're learning here in section 5.2. That factors into x plus something and x minus something, because you need to multiply to make a negative 14, so one has to be positive, one has to be negative. 14, really the only way that makes any sense here would be 2 and 7. Just make sure you have the 7 is positive and the 2 is negative. So when you multiply that out, you'll get positive 7x and negative 2x. So it'll come out 5x in the middle. This isn't all there is to learn about factoring trinomials. Remember, what we're learning here in section 5.2, this is the easy case. In section 5.3 that comes next, we're going to learn to deal with much more complicated problems, ones where the x squared in the front doesn't just break up x and x because there's some sort of coefficient we can't get rid of it. So see you next time for section 5.3.